Hello, everybody. Welcome to the Globe Educator 1 Week Pacing Guide webinar series. This is the first in our series, and we'll be talking about our clouds pacing guides today. We will get started. Jessica, do you want to introduce yourself?
Yeah, thanks so much, Angie. And good afternoon, good morning, wherever you're joining from. Thanks so much for participating with us today. To get started, we wanted to introduce ourselves and say a little bit about us. So I am Jessica Taylor. I am a physical scientist at NASA Langley Research Center, and I grew up in Florida. And one of the reasons I became an atmospheric scientist is I loved watching thunderstorms. And I was fascinated about lightning. And I had a great high school teacher. So thank you, all of our educators, who encouraged me to pursue that a little more and ask some questions about lightning. And what I learned was that scientists were actively still learning about lightning and they didn't understand it all. And I just thought that was so cool that you could have a job learning about something that was really interesting to you. And I really think that's what science is all about, is getting a chance to explore and learn about natural phenomenon. So I got my degrees at Florida State University. And actually, at Florida State was when I became part of the GLOBE program, which we'll be talking about today. And hopefully, you are already a little familiar with. And I started making measurements back then. And that really helped me build my confidence to pursue a career as a scientist because I already felt like I was a scientist by being a part of the GLOBE program. So I'm going to pass it back to Angie so she can share about herself.
Thank you, Jessica. So I also work at NASA Langley Research Center as an outreach coordinator on Jessica's team. And I taught middle school science for 12 years. I taught all the grades in the school because it was very small. And I also taught high school earth science and a math class every year. So I did a lot. And I started using Globe with my students in my last several years in the classroom. And it was such a wonderful experience for them. And it was so empowering for them. I got much better results. So I really wanted to help spread the knowledge and information about Globe further. And I joined the team about 3 years ago. So we're going to do a quick waterfall chat if you're not familiar with what that is. Everybody can enter your comment in the chat, but don't press the button until I say go, and then we'll see everyone's response at the same time. And we're just asking, what's your favorite cloud and why? There's no right or wrong answer. So if you want to type in an answer, I'll give you a few seconds and then I'll ask you to press enter. I see we have people from all over the place, which is wonderful. Thank you again for joining us. So press enter, please, and let's see what kind of clouds. Cirrus, cumulus, contrails, lenticular. I'm seeing a bunch of different ones. Great. So we have a little bit of knowledge here about clouds already, which is wonderful. And you'll see as we proceed, even if you don't know anything about clouds, you'll be able to learn. So we saw a need to have an easy way to start implementing Globe in the classroom or even with some informal learners. And so we have come up with these 1 week pacing guides. And tonight we'll be talking about what are the elements of the pacing guides. Then we'll go into details about our 2 different cloud guides. And then we'll do one hands-on, or actually 2 activities that we'll practice with, and then we'll just talk a little bit about how easy it is to implement them and taking it further. So if you want to participate in one of our hands-on activities that we'll be demonstrating, and you happen to have a piece of paper, a light source, and a few assorted translucent, transparent, or opaque items around, you'll be welcome to join along with us. If not, you can watch the demonstration. Okay, so for the overview of the pace, every pacing guide has an overview section. Let me go back one. They also have the NGSS science standards that are supported, some background information, 5 different activities in sequence, and then additional resources. The overview section, I'm just going to quickly go through. There's always a phenomenon. There is a grade level band associated with it. We have a guiding question on each pacing guide. This is a very important aspect of the guide. For our cloud types featuring NASA Globe Cloud Gaze, the guiding question is, what are the different types of clouds in Earth's atmosphere? We also have a contact. So if you have more questions about the content, the guide, anything related to it, you're welcome to reach out and contact the person. It's an email link. And then we have this little section that has a further investigation. This would be a connection to maybe a data challenge, maybe a specific globe campaign, maybe an intensive observation period, and they all relate to at least one of the Globe program's Globe Observer app tools. And then we have where you can access all the guides. So this overview section is at the top, and I just wanted to go through it because it's an easy thing to maybe glance past. Then we have the standards alignment. This here just shows elementary, but we show the performance expectations and the 3-dimensional aspects. We're not saying that we completely fulfill every one of these standards, but we do support them. And so we've put the time and effort into that for you. And I'm going to pass it off to Jessica to talk about the background section.
Awesome. Thank you, Angie. So in each of these pacing guides, we have put together some information about the content area and also a little bit more of a connection about why is NASA even interested and involved in this. So if you go ahead on to the next slide for us, Angie. So NASA has a really important job in monitoring Earth. And we do that by using that vantage point of space. And we have a lot of satellites, as you can see in this animation, orbiting Earth, collecting information and making measurements about all different components of our Earth system. There are several of them that record data about clouds, so not just one, but there are multiple ones that talk about clouds. There's some that are measuring sea level. I mean, there's just a multitude of ones that, and we'll be able to investigate a little bit more about the different ones, and you'll even see some connections to that in that background section. Go ahead to the next slide. So as we think about why NASA uses that vantage point of space, it's because we get this global perspective. And in this animation, this is showing modeled cloud and aerosols. So if the animation plays, you'll be able to see how using this vantage point of space, giving us this global perspective, we are able to see that these weather systems, these weather patterns really are moving, right? So one region's weather impacts are maybe slightly different than another, but you're able to see how it's all connected. And you can see that what originates from aerosols, so those purples and teals that you see here, those aerosols are originate in one location but travel somewhere else. And that's really the beauty and advantage of being able to use satellite instruments in space to monitor all of Earth. But the problem in monitoring all of Earth sometimes is that we have trouble with the details. And so at NASA, we like to fill it in and collect as much data as possible. So go ahead on to the next slide. And we do that by putting instruments in lots of different locations and on multiple what we call platforms. So platform is just whatever holds the instrument. So from top down, we are putting a number of instruments on satellites in space and at different distances from Earth. So we also put them on board the International Space Station, for example. We have a number of instruments that are Earth monitoring instruments looking back at Earth on the International Space Station. And we even can put them on a little bit lower. You see things like CubeSats. And at NASA Langley in particular, we do a lot with airborne missions. So what we mean by that are aircraft. And sometimes we put instruments on aircraft, well, to test out the instrument and make sure it works. But also we can then fly aircraft to a specific region of Earth that we think is interesting, and then collect that data and compare it back to the satellite to make sure that our satellite data that we're collecting, the algorithm and mathematical calculations that we do with that data are able to well represent all of these interesting parts of the world. And then as you get down towards the ground, you'll see that we do indeed still have instruments on the ground. And I want to call your attention to one specific area that says smartphones and citizen science. So you can play a role and your students can play a role in helping to continue to add data to fulfill and complete this picture, because each instrument tells us something a little bit different. And when you think about satellites in space looking down at Earth, the first thing that they're going to see from a cloud perspective is the highest layer of clouds. Now, on the ground, for us looking up, what we're seeing is that low layer of clouds first. So we're actually seeing and the bottom of clouds, satellites seeing the top. So we're seeing from two different perspectives. And by combining this information along with all of those other data platforms, we're able to get a much more complete picture. So hopefully that helps you get an idea of why we would collect all of this different data from different sources. It's because we need to put it together to better understand what's going on. And I want to share this very short video about why NASA studies clouds.
When you see fluffy white clouds in a blue sky, you know you're usually in for a pleasant afternoon. A sky full of thundering dark clouds, and you'd better find an umbrella. What could be easier than understanding clouds, right? Ha! When it comes to climate, clouds are far from simple. We know they're a very important piece of the puzzle, but they're hard to fit into the big picture. Why? One huge reason is that clouds both cool Earth by shading it from the sun and warm Earth like blankets, trapping the heat it gives off. Clouds cover around 70% of the planet at any given time, so they play a big role in determining how warm and how much water Earth gets. The thing is, scientists aren't sure how climate change is affecting clouds, or how clouds are affecting climate change, whether they're tipping the balance towards more warming or cooling, and how this will affect our planet in the future. For example, some places may get more rain, and some other places much less rain in the years to come as the climate changes. So NASA studies clouds from all angles to help scientists make their climate forecasts a lot less cloudy.
Great, thank you, Angie. So many of us are familiar with the really important role that clouds play, say, in water cycle. But clouds also play, and at NASA, we're very much interested in studying that component as well of clouds and water cycle, but we're also really interested in clouds and that relationship to energy budget. And you'll see that's why that particular pacing guide was put together. And Angie's going to talk through the rest of those components.
Yes. So one of the things that I wanted to talk about as we go into the 5 activities that are there in the guide is to pay special attention to the connection to the guiding question. We, every day, in addition to some sort of assessment option, there is a connecting question that goes back to that guiding question I talked about earlier, and the answer is there for the teachers as well. And so that helps you kind of build a story as you go through, or have this cohesive thread throughout your 5 days of activities. So the activities on the left, And then your assessment options and your connection to the guiding question are on the right. So on the first day in the cloud types featuring Cloud Gaze, there are 2 different video options, and there is a My NASA Data cloud sort activity that can be done. We have one page that probably many of you already saw when you registered for the webinar that has all the guides. And I'm going to just link out live to our cloud types guide. So here you can see the first day and the cloud sort activity. I just want to show you many of our My NASA data activities work this way. When I click on the activity, it's going to take me out to My NASA data, and you notice over here there's a slideshow. If I select that, it will force me to make a copy, and then if you have Google Classroom or something, you can assign this. I'm just going to give a super quick preview because we don't have time to run completely through this activity, but basically what it does is go through the cloud triangle that explains the basic types of clouds, the altitudes and the prefixes that are associated with those, talks about combining names to come up with things like cirrocumulus or stratocumulus. And there are some slides where they have the option to drag and drop some boxes. So it goes through and then talks about the only 2 types of clouds that make precipitation, contrails, and there's a one page where they can just match names to different types of all cumulus clouds. Then we have all different, on the next slide, stratus, and then cirrus, and there are more details. So that is one of the activities, and for this particular pacing guide, that helps them start to learn about clouds. And then that's the first day. On the second day, we're going to do NASA Globe Cloud Gaze. And what I'd like to do is, Jessica, if you could put the link for Cloud Gaze out in the chat, I'll give people we're just going to take about 2 minutes to do this because it is very quick. You do not need an account to log in and do this. But when you come out here to Cloud Gaze, you can scroll down under Get Started, and there is What Do You See? In What Do You See? There is a tutorial. I'm going to close out of that. You will be presented with pictures that have been submitted to Globe through cloud observations. And you can select different options, like I could say cumulus and identify, and then be done. And I may be right and I may be wrong. I can say, maybe this is stratocumulus. Done. This is a beautiful one here, right? Because I have, I'm going to say a cumulus, and then I'm going to say some cirrus up here. If you notice, some of the categories of ones that are difficult to tell apart are kind of combined, which is a great way to have a conversation with students about how sometimes classifying can be difficult, especially telling the altitude. It's also a great way to emphasize that it's just make your best estimation, because in this particular function in Cloud Gaze, we're going to have a certain number of people that have to agree on something before we retire the image. So that is another way that they can get out there and practice before they even go out and make observations. Then on day 3, they will actually go out and use the Globe Observer app and make a globe cloud observation. I am going to play this quick how to use the clouds tool video for you to see. So as you can see, there are a lot of great visual cues and assistance in this tool to help you make an observation or help anybody. This is where your photos come in to get sent to Cloud Gaze. So after day 3, when they've done the observations, on day 4, there are a couple of different hands-on options. One is to make a cloudscape. There's sort of a regular version of that. Then there's a tactile version, or they can do cloud in a bottle. And finally, on the 5th day, there is the globe program, Earth system poster cards, where they can coordinate between a bunch of different options. So that is great. The next guide is clouds and energy budget. And so we have very similar overview, but the different guiding question is, what is the role of clouds in Earth's energy budget? We've got background information as we discussed before. And on this day, our activities are going to be day 1. They look at images of net radiation with clouds and without clouds for the same time period to see what's the overall impact of clouds, hopefully discovering that overall they tend to have a cooling effect. And then on the second day, there is an activity about opacity where they design their own investigation to test materials to see if they are translucent, transparent, and opaque. The point of this is, do clouds all have the same opacity? Because it's the opacity of the clouds that can affect energy budget. And we'll be practicing this in a minute. But the key thing about that as activity on day 2 is, as we go into day 3 and we do this cloud opacity experiment where we have clear containers with black paper underneath, we put a thermometer inside and we shine a light. We really need an incandescent bulb for that. And we are modeling clouds with different kinds of cotton balls. They're going to see the temperature differences. So you use really thick cotton to show like the low cumulus clouds, and you use some really spread out and thin cotton balls that you've kind of, pulled apart to make high level cirrus clouds. And they're going to see that there's warmer temperatures under those cirrus clouds. On day 4, they'll go out and make a cloud observation, again, as they would have in the other guide. And then on day 5, we have a great video with Dr. Patrick Taylor, and they can examine a simplified version of Earth's energy budget. Both of these guides have additional resources also, and we've indicated sort of the audience for these resources in a brief description. And Jessica is going to lead you through that opacity cloud clues activity.
Yeah, thanks, Angie. So as you looked at the 2 different pacing guides, hopefully you're starting to get a feel that, we made some really difficult decisions in picking just one activity for each of those days and how to sequence them. But this is just our guide to you. You are educational experts. Feel free to mix and match in whatever way best suits your needs. And we'll talk a little bit about how you might do that even with this activity. But this is the activity that, Angie, this was day 2, correct, on the clouds and energy budget pacing guide?
Correct.
And so this activity is all about, how do we design an experiment that we could do to help figure out the opacity of different materials. And this activity was developed by a wonderful group called SciGirls, and we do have an episode with SciGirls if you want to look that up. And it is really honing in on categorization and going through these materials, but really the point of this activity in terms of why it was designed at a middle school level, because opacity and certainly categorization are more elementary level, is if you think about the idea of just experimental design, right? And think through that part. So go ahead to the next slide, and I'm going to take off my background to show this to you. So you can do this along with me if you would like, and just find a few things that you can use that you might have sitting around. And how could we test? How could we test to see if a material was transparent, translucent, or opaque? And ask the students to draw or write out how they might do that. And so I'm going to show you mine, which is, I am not an artist, I'm a scientist. So I'm going to use my phone as a light source, and I'm going to shine it on my material. I'm going to use some cotton. You can ask the students to pick whatever they're interested in testing. And in this case, I'm actually going to shine it directly at the computer. So here's my phone here, and I have some paper towel, and I'm going to fold it up because I want to see what happens if it's a very small paper towel. So take a guess as to what you think this might be for yourself, and I'm going to shine my light right here. Can you see my light through that? No, you can't. So when it's all folded up, there's no light. But if I open this up, do we think that might be different? We see some, right? So let's see what else we can test here. So I have some tissue paper. And yeah, you can see a lot of light there. Now, I also have these little cotton pads. So if I put a bunch of them together, this might be what we might imagine a thick stratus cloud, right? Because I've got multiple layers here might be like. And if I point it through, all right, we're seeing a little bit, and then I could add more. Right, this is meant to be a fun activity about testing and design. Now, what if I took one of those cotton pads and pulled it apart, like Angie was talking about for the next day's activity? We really want to test between, say, a big puffy cumulus cloud, which might be best represented with our cotton pads that are all together in a thick layer, or say maybe a thin high level cloud like a cirrus cloud that is all pulled apart, right? And in this case, you could see a lot of my light, right? And so you can see how you can play with this activity to get it to match a little bit more with that next activity where we're really starting to talk more about clouds. So Angie, move on to the next slide. And what you would have the students do is go through, and on the piece of paper underneath transparent, translucent, and opaque, they'll write down all the different materials that they tested out. And like I said, really designed for it to be fun for them to be inquisitive about what different materials, what categories they might fall into. One more slide. So how does this all relate back to clouds, right? That's the whole point of this and that guiding question. And so again, those low-level clouds, something that is best represented by like a big puffy cotton ball or these cotton pads, they're going to block a lot of that sun's light from reaching Earth, right? They reflect that back. But one of these types of clouds So they're opaque, right? One of these types of clouds, one of these cirrus types clouds, they let the vast majority of that light through. So if you see that arrow on the far left side, that sunlight is not reflected back to space. It's basically letting it all in. But what's more is that not only do they have this impact on incoming solar energy, these clouds also actually have a different impact on outgoing energy, the energy emitted from Earth. So those high, thin clouds also now trap a lot of that heat because they're so high in the atmosphere and so cold that they emit much less energy back out into space. And that's how these are related. And this is why when you make an observation with GLOBE about clouds, we ask for more information than just the percentage cover and the cloud type. We asked you to think a little bit more about that cloud type and tell us that opacity because it's a really important factor in us better understanding climate. All right, let's move on to the next slide. So now that you've had a chance to hear a little bit more about these pacing guides, I'd like us to do another waterfall activity. Think about implementation and how these pacing guides might help you incorporating this content into your classroom. So I'm going to give you a few moments to come up with an answer, get it ready in the chat, and then we'll count down for the entries. So what about this might help you with implementation? All right. I hope you're ready because I would like to see your answers. 3, 2, 1, enter. You're all still thinking. Breaking it down into smaller components. Yeah, so one of the things that we see in the pacing guide is we have this guiding question. And then on each of the days, we are trying to tackle one component of being able to answer that guiding question more fully. And you'll see, as Angie showed, that there are even these quick assessment ideas for how to see if we're on track. So this way you're able to tell, all right, are they following along, or do you need to revector and go over something else? Thank you, Leslie. Janelle, I see hands-on aspect. We have gone through great lengths to make sure that in every pacing guide, there's a GLOBE citizen science data collection activity, a My NASA data activity that includes real NASA data, and then some other component of hands-on investigation experiment. And where possible, we have some digital versions of that as well for those of you who might be doing some remote learning. Yeah, hopefully, thanks, Chandra, the opportunity to let your students think more deeply. That would be incredible if we were able to give them that opportunity. Angie, is there anything else you want to add here?
I'm just liking these comments that they are appreciating the standards as well, and that it can help them build an incremental story. And I like that it goes beyond just cloud identification and allowing them to be a part of citizen science. So it says they're great for students who wonder, when are they ever going to use this? I really like that because that is something that you hear a lot. Yeah, so we did try to make this something that you can implement easily, but remember all those additional resources too at the end of each guide. If you ever want to customize it, you are able to do that. And one thing I also would like to point out is that if you have the time, you could use both of these guides. You could do the cloud types with Cloud Gaze first and then move into the energy budget guide. And another thing that you could do if you feel that your students really have a grasp of transparent, translucent, and opaque, but they don't really know cloud types yet, you could do the energy budget guide and replace the first 2 days on the energy budget with the first 2 days on the cloud types, going over that cloud sort and cloud gaze, and then go into the opacity with the cotton that we talked about, and just make a real effort to make that opacity connection with your students and go on. And so you could combine those two guides in that way. But we really, in my perfect world, I'd love to see someone implement this guide, and then the next time they did it, they would tweak it for their specific needs, or even before. And but then they're having success with Globe. So
absolutely, yeah. So this is just our think of it as the base model, if you will, and you can make any additions and changes out that you feel are necessary. So we just have a few more slides because we want to tell you about some really interesting and exciting things related to Globe Clouds, and then we will take questions, and we will also share out a slide deck. I was able to capture the link for our slides. So one of the things we wanted to mention is that one of the exciting parts about submitting your Globe data to Globe, whether that's through the Globe website or through the Globe Observer app, is that data actually comes to us at NASA Langley, and we will check to match it in space and time with various satellites. So we are currently matching to Aqua, Terra, and Calypso. They're polar orbiting satellites, and then a number of different geostationary satellites. And so because we're matching to geostationary satellites, which are the ones that are basically kind of stationary over your location, and we are matching to multiple geostationary satellites in different regions, almost any point in time of day and locations on Earth, you'll be able to get a satellite match. And what we mean by that is we send you a personalized email after we get your data, and we will send you a table that looks like this with your observation and then what the satellite collected. And it's very interesting to look at it because you'll be able to see that sometimes they match really well and sometimes they don't. But that doesn't mean your observation's wrong. Remember, you have completely different perspective than the satellite. And so sometimes we need your perspective because something was happening that we couldn't see. So it can be an extra added feature, particularly for some of your students who might get really interested and want to go a little further with clouds, is to add in this component of satellite comparison. And then next slide, we have something very exciting going on right now with a number of resources that are on our Globe social media accounts and on this webpage that I'll pop into the chat here in a second. But we have a Globe Clouds Data Challenge going on right now, Clouds in a Changing Environment. And so in the next slide, we have just a little promo video about this.
Did you know that clouds can both warm and cool our planet? Keeping an eye on clouds helps NASA study our climate. We need your help capturing data about clouds where you live. NASA Globe Cloud Challenge 2022, Clouds in a Changing Climate. January 15th to February 15th, 2022. Participate by taking cloud observations with the Globe program's Globe Observer app. Or by classifying cloud photos through Cloud Gaze on the Zooniverse online platform. Learn more at observer.globe.gov/cloud-challenge-2022.
So some of you who may be familiar with Globe know that every once in a while there are
Did you
data
know that clouds can both
challenges,
warm and cool
what
our
we call kind of intensive observation periods. And so this is an opportunity where we can encourage everyone in the Globe community to collect data on something specifically and send that data to us. So this challenge in particular that we're running right now is through February 15th, and we welcome you to go to that website and hear from other scientists who are sharing out how clouds are important in this changing climate. And there are also Globe student vloggers. If you have not had an opportunity to learn a little bit more about the Globe community, I recommend you watch some of those Globe student vlogger videos, because that's a great way to begin to understand a little bit about the breadth in terms of the multiple countries that participate in Globe, and even just kind of what it means to be a part of the Globe program. So I'm going to leave it at that, and we will go ahead and take questions. And I will, as we start to open up questions, feel free to put them in the question and answer box, and we can also try to follow along in chat. I'm going to grab that link for these slides, because I know somebody earlier did ask for that.
So I see a question in the question and answer saying, how do we simplify the satellite match data to younger students in grade 5 and 6? One thing I would recommend is maybe just look at like the overall percentage matches and see how that is. But also that picture that we showed with the different perspectives, maybe have that there for them to see, so they can think about what did the satellite see and what did they see. And I also would say, I think for 5th and 6th graders, that maybe the first time or two that they go through it, they'll need a little coaching, but I have confidence that they can get used to it and that they can do it with some practice.
Yes, so Angie, I remember one time we've even done an activity where, if this was our satellite match, folding it up so that way we're just looking at one of the rows at a time, so that it's not overwhelming, right? And just focus on one row at a time. And maybe for your students, there's only 2 rows in particular that you even want to talk about right now. So maybe that's cloud cover, and maybe it's one other thing, or maybe it's the image itself, right? Because it's pretty cool to see the image and see it on your location.
Right. That was the other thing I was going to say, is it's and you can click on those images and get them bigger too if you look at it on on a computer, and so they can see their photos and they can see the satellite image, and that's also a really good way to emphasize scale and proportion, right? And the bigger versions. And I saw in the comments too that Helene made a great comment about, so we match within 15 minutes of the observation. And so Helene commented, sometimes 15 or 20 minutes between the actual observation and the satellite image can make a big difference. And that's true. And that's another thing you can emphasize with the students. So it's because we all know we can look in the sky and we can see clouds moving, right? So how much could they change in 15 minutes? Maybe a lot.
Yeah, I think that's certainly one of the reasons why we get the most number of observations in globes related to clouds. It's because it's changing all the time, right? And you can make that observation multiple times in the day, even if you wanted to.
Oh, and Helene said the pictures often document the changes. That's really neat. That even sounds like a great project idea to me. And there is a notification option in the app that you can get notified when those polar orbiting satellites will be coming over, so that you can time those observations. Like we said, the geostationary ones, you get a lot more matches, but you do need to time them to get your polar orbiting satellite matches. So I get notified every day, multiple times, because there's more than one satellite, but it is really nice.
And if anyone has any other questions, feel free to type them into the chat.
Yes, and I'm also going to put my email in the chat. So you can always email me with any questions.
Leslie has a question about the app is called Globe Observer. The Globe Observer app is the app for the Globe program. So if you, for iOS or Android device, just search for Globe Observer and you should be able to find it. It's a free download. Now, for some of you who are kind of thinking about how do I use the app versus anything else, so within Globe and in that pacing guide, you will also find the links to where you can get the paper data sheets. So maybe if you want students to go out and work in teams or individually on a paper data sheet and then put it in the app, there are all sorts of ways and there's no one right or wrong way. It's however works best for your classroom in terms of collecting that information and then submitting it back to Globe. So depending on the age of your students, if they were older students, so over 13, and they had access to the app directly, they might be doing it individually. Or you might be as a classroom making an observation together and then forming some consensus and then submitting that. And the teacher could even submit that.
I see there's another question that relates very well to that about if they have the 4 students standing back to back to make an observation and they're using the app, would they take a picture of only their portion of the sky in front of them or all 4? So I think, it doesn't require you to take all the photos, but you certainly can. So that may depend on what you're wanting to look at with your students. Ideally, I would say more pictures are always better for an observation, but if you want them to just focus on their part of the sky, that is okay. And you can even make an observation and skip the pictures. So it doesn't require them. The pictures are the most valuable for the scientists, I believe.
And I also wanted to mention, we would love and welcome your feedback on how this goes. Right, so this was our first time putting together pacing guide like this. We received a lot of input from others on the content from both the science perspective as well as from the education, the teacher practitioner perspective. But we would like to hear, once you actually start trying to use it, how it works for you. If you would see recommended changes to the format or different types of resources, we would love to hear that. And we were talking about making sure to be adding dates on these pacing guides, revision dates, so that way in the future you can see if there are any changes to them. And these can be living documents in terms of, you're welcome to, as you use them, change them up to whatever best meets your needs and whatever resources that you find work for you. All right, I'm not seeing any additional questions in the chat. We really want to thank you very much for taking time out of what we know are your incredibly busy days to join us to learn more about the pacing guide. But thank you for your excitement and enthusiasm in doing Globe and doing Globe with NASA included. And we really appreciate your time. Thank you.